Today is day 375 of data science. It is also Thursday, July 28th, 2022. And today I'm going to solve this problem. I basically have to find the area or the proportion below a certain point or a certain value using a normal distribution. And I'll first just find the answer super quick using Python, and then I'll do it by hand. And by hand, I mean with the calculator. That's how you would do it in your normal class, because you can't really do this without a calculator. With the TI-83 and then the TI-84. All right, so basically it's asking what proportion of students' heights are lower than Faisal's height. So for this, I'm going to have to use my normal CDF function, and in Python, I can get that by importing that from scipy.stats, import norm, and then from norm, I can do norm .cdf. And then I can put in my three values, which is going to be my x, my mu, and then my sigma. So my x is going to be basically the point of interest, right? The point that I define it as the point that I'm going to find the area below or above, right? So whatever that is, in this case, it's 103.1 centimeters. How do I know that? Because that is the point that they're trying to find the area below, right? Lower than that. So I'm just going to put 103.1. And then in Python, mean is loc. And so for that, it tells us 105. And then the scale, which is a standard deviation, is 10. And I can just run that, and it's going to give me 0.4247. And it says to round to 4 decimal places. And so I'll just do round and put that in there. 4 decimal places, and then just copy that answer and go to Khan Academy, paste it in there, see if I'm right, and I am. Okay, so that's basically the shorthand. Normal CDF in Python, by the way, just calculates the proportion or the area below a point. So if this were to ask what was the proportion or area above a point, I would have to do 1 minus this answer, right? So that would have been like 57.53%. Right, of students who had a height above 103.1 centimeters. Or I could have done the equivalent to 1 minus CDF, which is just SF, and it's going to give me the same answer. So that's that. Okay, so now I kind of want to graph it to give a visual of what I'm actually finding the probability of. So in order to do that, I'm just going to import matplotlib real quick. This has nothing to do with actually solving the problem. It's just, I just want to make a graph of what we're doing. So import matplotlib.python-splt, and then in a graph, I obviously need x values, and I also need y values. And so for my x values, I'm going to have to import numpy, as np, because I want to be able to use a linspace function, which basically allows for 3 parameters, the start, the end, and how many values in between. So in a graph, right, you start with a number, you end with a number, and then you have values in between. And so I kind of play around with that by reading the problem. So if the mean is 105, then I would just maybe do something like 90 as a start, and then I would end something like 120, and then have 1,000 values in between. And then it might not be perfect, and we can switch it after we see the the graph, but I kind of estimate like that. And then for the y values, I do PDF, which is a probability density function. And what's the difference between PDF and CDF? Well, PDF calculates the specific probability or the specific area at that specific point, which makes sense in a graph because we want the specific density of each x value, right? With the log being, in this case, 105, which is the mean, and the scale, the standard deviation, being 10. All right, and now I'll just plot it. So I'll do plt.plot because I imported matplotlib, which is a visualization graph library, and I can plot my x values and my y values and run that, and it should give me a normal distribution. Now notice it's kind of not that great, and so maybe now I can go back and kind of adjust my values to be maybe 180 and, I don't know, 140. Let's see how that looks like. and it's a little bit good, but then it's also not, so maybe 50 to kind of have it. Nope, 60, 70. All right, that looks a little bit better. All right, so see, you could just play around until it looks normally distributed. So, yeah, so now I just like to always add a title because it looks nicer. Normal distribution of students' heights with mu, which is the mean. Let me just get that symbol. Let me go back. Mu of, what was it, 105? And sigma of, oops, are you serious right now? Oh, what did I say? 100 and, oh no, it's just 10. Okay, run that and the title should appear, right? And then I could also do plt dot x label, and this is going to be students, or I could just be like, I could spell it. All right, and then plt dot y label is going to be the proportion. It could also be area, or it could be density. All right, and that's it. So now I like to save that or copy the image and go to my whiteboard and kind of figure it out by hand. Okay, so I just paste that in there, and then I also lock it. All right, so okay, let me just connect this. 1 second. Okay, move that here. Oops. All right. Oh, what happened? Okay. Let's see. What in the world just happened? Okay, hold on. Technical difficulties. All right, so in this case, the problem is asking us what proportion of students' heights are lower than that of, I literally forgot the name of the person. Why are the names in Khan Academy so hard to pronounce? Okay, let me go back. Faisal's. Okay, Faisal's height. So that's the question, right? So in that case, Faisal's, well, I can't say it. Faisal's height was 103.5. So that's about right here. That's 103.5. And the question is, what proportion of students' heights were lower than that? So the area that we're trying to find is everything to the left of that point, right? So this yellow area over here, which is fine. So with Python, just to kind of review, with Python, I had just done, my normal CDF function, which in this case I got from scipy.stats, right? So I did norm.cdf, right? And I just put in my 3 values. So in this case, x was 103.5, mu was 100 and I completely forgot. 105, right? Makes sense. Or was it 100? It was 105 and then 10, right? And then that gave me my answer, which was 0.44 something. Let me check. 0.4247, not 44. 105, okay. 40. I literally just read it and I forgot what was the answer. 42, 47. Okay. 42, 47. 0.4247. And so that's the proportion of students' heights that were lower than that of Fasal's height, right? Or if you want to be more specific, you could just do 42.47% of the students' heights were lower than that of Fasal's height. All right, that's with Python. Now I just wanted to know if it were to ask for this area over here, that meant if they were to ask what proportion of students' heights were higher, then I would have had to do 1 minus the yellow area right? Because in Python, CDF only calculates the area to the left, right? So it's okay to just use norm.cdf for if it's asking for like the area below or to the left of a point, but if it's asking for the area or the proportion above, by the way, area and proportion, same thing, means the same thing. If it's asking for the proportion above or higher than a certain point, then I would have had to do 1 minus the yellow, right? Which makes sense because 1 minus the yellow gives me this area over here. Or I could have just done the Python equivalent to that, which is norm dot SF, right, is equal to 1 minus CDF, right? So that's just a side note there. Okay, now with the TI-83, the way you get to use the actual function is if you go to second, which is like the yellow button, it should be yellow, and then you go to vars, which should be under like the arrow buttons and like next to the clear and the program button, um, and then you click on 2. So it should be second. Let me just do it as I'm writing it down. So second vars 2. It's a normal CDF function, right? And so in the TI-83, it literally doesn't tell you the values. Like you would just have to know it. So for in this case, the values are lower bound, upper bound, mu, and sigma. Mu means mean, by the way, and sigma means standard deviation. So in Python, I guess it's a little bit harder because you have to know like when you have to subtract from one and etc. But in the TI-83, you can literally just put the interval, right, of the area that you want to find, and you don't have to worry about 1 minus anything. So for example, my lower bound is the point where I want to start. So in my case, if I want to find the area below this certain point, then I have to start through negative infinity, right? So my lower bound is going to be negative infinity, but here's the problem. In my calculator, there is not a negative infinity button. So you would have to use -1 E99 because it's basically an arbitrary. Did I pronounce that right? Arbitrary. Hold on, we have to take a second because I really cannot even read names. I can't do anything.
Arbitrary.
What?
Arbitrary.
Arbitrary. Okay, whatever. That word, number, right? That's not exactly negative infinity, but it represents it because it's a really, really big number. So where's my stuff? Okay, where's my pen? I'm literally all over the place. Okay. Oh my God. All right, back to work. I just got a call. Okay. Um, so for negative infinity, I just do -1 E99, right? Okay, so lower bound is -1 E99. In the calculator, you put -1, and then E99 is, hold on, -1. Where is E99? I forgot. Oh, it's not E99, it's just E. So in the calculator, above the 7 with the comma, there's an E sign, the yellow, so you're gonna have to do second. So first it's a -1 and then second comma and then 99. That's how you do it. Okay. Took me a while. All right. So that's lower bound and then upper bound, right? That interval, let me get rid of this. That I'm stopping at is my x, right? It's my point, right? That I'm trying to find the area below it. So it starts over here at -1 E99 and it's ending over here at my x point, which is 103.5. So this would end up being my x, technically, if you want to relate it to Python. So it's 103.5, and then this stays the same, 105 and 10. And then if you just click enter, so let me do it as I do it. So second vars 2, -1, second comma 99, comma 103.5, comma 105, comma 10, end parenthesis, enter, it gives me 0.4404. Interesting. If I were to put that answer in Khan Academy, would that have worked? Because it's not the exact answer. 0.44. What did I just do? Where is my Khan Academy? Can I not change the answer? Oh my god, I can't. 0.44. Negative 1 E99, 103.5. They're using z-scores though. Yuck. No way, it was 103.1. Where's my data science stuff? Where is it? 103. Oh, it is 103.1. See? Oh my god, I was so scared. I was like, why am I getting a different answer? All right, so let me just fix that real quick. Control, I need second entry and change that to 103.1. This is what I get for not looking back. All right, and then all right, even over here, I wrote it down here, but don't worry, I did it right in Python. All right, 103.1, and then that gives me 0.4246, but rounded 7, and that's the same answer that I get over here, right? Perfect. And now with the TI-84, the TI-84 is a little bit easier. So it's the same thing. You go to second vars 2, and then it literally gives you options. So lower, upper, and then it does mu and sigma, and then there's a paste thing. I don't have a TI-84, I just remember. It's, I used to borrow my stats teacher's calculator because I didn't have a TI-84, and I kind of just remembered. How do I go back? All right, so from my memory, this is what it gives you, right? So the lower is the same thing. You just put in negative 1 E99, upper 103.1, 105.10, and then there's this paste thing that when you hover over it, it turns black, and then when you hover over it, just press on enter, and it should give you, right, 0.4247, and then that's your answer, okay? Yeah, so that's it with Python, TI-83, and TI-84. And that's literally it. Yep, that's pretty much it. Okay, I don't know if there's anything else I want to say. It gets a little bit more complicated for Python, again, when it's asking for area above or higher than a certain point x. But I already did a video like that. I don't know. It's not really that complicated. I already explained it at the beginning. All you have to do is just norm.sf and then plug in the same values and it'll just give you the area above, which is the same thing as doing 1 minus CDF. But yeah. All right, that's it for today then. Bye.